Great. So welcome to the lecture for week 8 of Introduction to Logic, Philosophy 1500.02. Anyway. Sorry, so I've been out of town and sick this week. So I will try to struggle through this. Anyway, the lecture is on prose arguments, right? So what we're going to be doing today is putting together everything that we've done in chapter 6, right, over the last few weeks, right? So we'll be taking arguments that are in like English prose, right, translating them into symbolic notation, right, and then testing them for validity, right? So in some ways, this is just a big review of what we've done in chapter 6 in the book, and that's good, right? So what we've done over the last few weeks, we're just going to try to solidify our understanding of that, right? So this is sort of like pulling back on the reins as well, right? No new material, really, just putting together what we've already done. So good, yeah. Anyway, so if in the last few weeks there was something you didn't get, this is a chance to make sure you get it, right? Because this is in some ways like the heart of the course. All right, so here's the big idea, right, that we're working with. So we can use everything we've done so far to determine if prose arguments are valid or invalid, right? So sort of what we've done so far with these big truth tables for arguments is just look at arguments that are in like symbolic notation, right, and tested them for validity. But as I'm sure you've always kept in the front of your mind, right, these symbolized statements, they're instances of English sentences, right, and English arguments. So what we're going to do to do this, right, to determine if prose arguments are valid or invalid is we'll start with identifying the premises and conclusion. We'll translate that into sentential logic, right? That is the stuff with like horseshoes and dots and all of that. We'll construct a truth table for the argument. And finally, we'll use the truth table to determine if the argument is valid or invalid. Right, so again, all stuff that we've done before, although we've never put it together in this way before. Right, so we've identified premises and conclusions in arguments before. We've translated statements into sentential logic. We've constructed truth tables, and we've used truth tables to determine if arguments are valid or invalid, but we've never done that all from start to finish in this way, right? And that's just what we're going to be doing this week. So again, kind of just review. Okay, so in a sense, this is what we've been building up to in the last few weeks, right? So that's exciting, right? And by the way, we're almost, I guess, halfway through the semester, something like that. So we'll have this week, next week, and then I believe spring break. Okay, so here's a warning, right? To do all the stuff that I've described, right, you need to have mastered all of the previous material, right? That's why I've been emphasizing the reviews. So if you haven't mastered the previous material, right, this is a chance to like identify what you haven't mastered and to master it, right? If you don't, then this is just going to be a disaster. Right, so here's the upshot, right? So if there is something that you haven't mastered or that you're shaky about, right, you need to review it, right? You learn by doing this sort of stuff. Okay, so here's sort of more stuff to say along those lines, right? So since we're applying what we already know or what you should already know, right, you should know this, we're just going to do some examples, right? So I'm just going to presuppose that you know what you're doing. So if there's any point in this lecture where you're unsure what it is that you're supposed to be doing, right, please email me and tell me what you're confused about, and we can sort it out. So here's an example. We'll go to the RPAC only if it's not raining, but it's clearly raining, so we won't go to the RPAC. So we want to know whether or not this argument is valid, right? So what we're going to do, right, to start is identify the premises and conclusion, translate the statements into sentential logic, construct a truth table, right, and then test the argument for validity or invalidity. Okay, so to start, what are the premises in the conclusion? Well, suppose someone were to say this to you, we'll go to the RPAC only if it's not raining, but it's clearly raining, so we won't go to the RPAC. Right? They've made an argument. So the question is something like this. Well, what is it an argument for, right? If you can identify that, then you can identify the conclusion. One sort of hint here, right, is that we have so, comma, right, which is a conclusion indicator word, right? So let's start with that. So I'm going to highlight premises in yellow and the conclusion in green. Here's our conclusion indicator word so. All right, so next, let's identify the logical connectives. So what do you see here? What sort of logical machinery? Well, we have only if. Anything else? Well, but maybe, but we should ask whether or not but there is playing a role as a logical operator. I see some nots. It's not raining. We won't go to the RPAC. Okay. So note that I didn't underline but in but it's clearly raining. Here it's not playing the role of a conjunction between two statements, at least not obviously. You could conjoin it to the whole previous sentence, but you don't have to. Okay, so let's choose sentence letters for simple statements. So we have two different statements here, right? So we'll go to the RPAC, it's raining, right? And all the other statements are built up out of those plus logical operators. So we'll go to the RPAC, let's symbolize that as G and it's raining as R. So now we should symbolize this, right? So you should pause me and symbolize this and then turn this back on and see if you got it right. All right, so here's what I came up with. G horseshoe tilde R for our first premise. That is, we'll go to the RPAC only if it's not raining. Right, so that is to say it's equivalent to we'll go to the RPAC, or if we go to the RPAC, then it's not raining. Premise 2, it's clearly raining, which is R. So, conclusion, we won't go to the RPAC or tilde G. So next we want to construct a truth table for this, right? This is the argument that we've made, right, and that we've symbolized using the prose argument. So to start, it should look like this, right? So we have true, true, false, false under G, and true, false under R. We have our two premises and then our conclusion. Okay, so if you haven't constructed the truth table yet, you should pause this and do it, right? And then solve the truth table, right? So please pause this and then come back when you figured it out and we'll walk through it. All right, so one thing to keep in mind, there are 4 rows here, or 4 lines. So why is that? Well, the sort of technical answer, I guess, is that we need 4 rows or lines to depict all of the possible combinations of truth values for G and R, right? Another thing you could say is that there are 2 simple statements, G and R, right? And the number of rows, or lines or rows, is given by 2 to the n, where n is the number of simple statements, so 2 to the second is 4, right? But the idea is that we need all these rows to depict all the possible combinations of truth values that G and R could have, right? We don't want to leave any out, right? Because the combination we leave out might show that the argument's invalid, right? And we don't want to put any more in because, well, we would just start repeating combinations, and that would be a waste of time. So we want 4, so good. So let's see what we should have come up with. So you should come up with this initially, right? This is just going through and putting the truth values underneath the simple statements. So in our first row or line, right, we have true, 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 true going across. So that is under both G and R, we put true, right, because those are all true in that row. In the second one, we have true, false, false, true, right? So putting T under G and F under R, and then so on. Right, so what do we do next? Well, that's right. We'll start solving for the individual ones, working from roughly the inside out. So let's see where we begin. So this is what you should come up with. So let's start in the conclusion. We have that tilde G, right? So we're just going to flip the truth values, right, from true, true, false, false to false, false, true, true. Second premise, we didn't have to do anything to. First premise, right, what we needed to do was solve for the tilde on tilde R first, and then for the whole thing, right? So the tilde on tilde R is false, true, flipping the truth value again. And then we combine that with what's under G to determine the truth value of the expression if G, then not R, right? And that's false, true, true, true. Okay, so that's what you should have come up with, right? So now we want to use this to see whether or not the argument's valid or invalid. So how do we do that? All right, so the pause there was for you to say, I assume you said something like this. We look to see if there's any row where the premises are true and the conclusion's false at the same time, right? If there is such a row, then the argument's invalid, right? Because such a row would show that it's possible for the premises to be true and the conclusion false at the same time. Okay, so is there such a row? Again, we're looking for a row where the premises are true and the conclusion's false. Is there such a row? Well, here's our first row where we have a false first premise, true second premise, and false conclusion. Is that a row where the premises are true and the conclusion's false at the same time? No, right? So that one's good. What about the next one? True, false, false. Again, not a row where the premises are true and the conclusion's false at the same time. So that one's good, so we can put a little check mark there. Third one, true, true, true. Well, is this a row where the premises are true and the conclusion's false at the same time? No, right? The premises are true and the conclusion is true, so that one checks out. And then finally, true, false, true. Again, not a row where the premises are true and the conclusion is false at the same time, so that checks out. Okay, so there's no such row where the premises are true and the conclusion's false at the same time, so we can conclude that the argument is, that's right, valid. Good. So I want to call your attention to the third line or third row where G is false and R is true. Note that the premises are true and the conclusion is also true. Does this show that the argument's valid? Well, not by itself, right? We need to know that there's no row where the premises are true and the conclusion's false. So there might be a row where the premises are true and the conclusion is true, but that doesn't show that the argument's valid. Right? What does it show, though? Well, nothing by itself, but if the argument's valid, that is, if there's no row where the premises are true and the conclusion's false at the same time, and there's a row where the premises are true and the conclusion is true at the same time, right, then we know that the argument's valid, right? And we also know the situation or situations in which the argument would be sound. Right? So here the argument would be sound in the situation where G is false and R is true, right? Because not only would the argument be valid, right, which is sort of a global property of the truth table, but it would also be sound here because the premises would be true and the conclusion would be true. So cool. Right, so the argument's valid. Okay, so that's what we're going to be doing each time. So let's look at some more complicated examples, right? Because that one was pretty easy. So here's one. If you enter the teaching profession, you will have no money for vacations, and if you do not enter the teaching profession, you will have no time for vacations. Since you must either enter or not enter the teaching profession, it follows that either you will have no money or no time for vacations. Okay, so this is a somewhat long prose argument. Let's try to symbolize it, right, and determine whether or not it's valid or invalid. So it's good at this point, right, to just sort of reflect on what you're going to do to solve this. So I'll give you a moment to do that. So think about, like, what do I have to do to solve this, right? So what strategy are you going to employ? Right, we want to figure out whether or not it's valid or invalid. So pause me and think about it. All right, so the thing that you're going to do, right, is begin by identifying the premises and conclusion. Second, you're going to symbolize the statements into sentential logic. Next, you'll build a truth table. Next, you'll solve the truth table, right, and then you'll use the truth table to determine if the argument is valid or invalid. Right, so let's get started. Or rather, here's what you're going to do, right? Again, so just to say it again, you'll determine the premises and the conclusion, you'll symbolize them, you'll construct the truth table, and then you'll determine if the argument's valid or invalid. Okay, so what are the premises and the conclusion of this argument? Well, there's a really big conclusion indicator clue here, right? It follows that. Right, so here's what I would say the argument is set up as. So premise 1, if you enter the teaching profession, you will have no money for vacations. Premise 2, if you do not enter the teaching profession, you'll have no time for vacations. Premise 3, either you enter the teaching profession or you do not enter the teaching profession. Conclusion, either you will have no money for vacations or you will have no time for vacations. All right, so now we want to symbolize this. Right, so I would recommend pausing the video and trying to do this on your own. All right, so here's how you should have done this, right? So begin by identifying the logical, sorry, what's the word I'm looking for? The logical operators, sorry. So premise 1, if then. Premise 2, if then, do not. Premise 3, either or, do not. Conclusion, either or. It occurs to me you could have done a little bit more in the conclusion than I will do, but it won't make a difference. You could have said, have no money for vacations is something like, it's not the case that you will have money for vacations. And similarly, with you'll have no time for vacations, you could have done, or it's not the case rather that you'll have time for vacations. But these won't matter. Right. Importantly, the reason it won't matter, right, is because elsewhere in the argument we haven't put that structure into the various statements. If that didn't make sense, don't worry about it. Okay, so here we are, right? So I've gone through and I've highlighted the various statements and how they should be symbolized, right? Which statement letter you should use. So wherever you see green, you should replace it with the same statement letter. Wherever you see blue, you should replace it with a different but the same for each blue instance statement letter, and then similarly for yellow. So I've just chosen E, M, and T. E for you enter the teaching profession. M, you'll have no money for vacations. And T, you'll have no time for vacations. So again, try to symbolize this. You can pause this, do it on your own. So I got this, E horseshoe M, tilde E horseshoe T, E wedge, not E, M wedge T. right? So good. So this is what you should have come up with. Right, so next we want to build a truth table for this. All right, so here's a question. How many rows is it going to have? Well, how many simple statements does it have? E, M, and T, that's 3. Right, so the number of rows will be 2 to the n, or 2 to the third, right, in this case, where n is the number of simple statements, different simple statements. And that's what? 8. So take a moment and set up your truth table, right? Like, it's very important that you do this. All right, so this is what you should come up with. Under E, you should have 4 T's followed by 4 F's. Under M, you should have true, true, false, false, true, true, false, false. And under T, TF, 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 TF. It occurs to me to mention right now that it's probably not the best idea to use T as a simple statement, just so you don't get it confused with truth value, but in any case, here we are. So don't do what I do, or did here, at least with respect to symbolizing one of the statements as a T. Okay, so construct this truth table on your own if you haven't already, and solve it. Right, so pause the video, take time to do this. It should take, I don't know, 2 or 3 minutes. All right, so here's what I came up with. So that's a lot all at once to be dumped. So what I suggest doing right now is pausing this and comparing this to your own work. Right, so this, I assert, is valid, right? You'll have to check this on your own, I think.